وتقود قطاعاتها إلى التميز والابتكار، ولنستمتع بكل إبداع بين ثنايا أجندة مؤتمرنا الذي سيكون معنا فيه أساتذة ومتحدثين ملهمين نروي قصة نجاح لا تنضب، حيث تلاحق الإنجازات والتحديات على مدار مسيرته المهنية الحافلة بالإنجازات ومواكبة التحول المؤسسي الرقمي. هو متحدث عالمي ومخطط لمستقبل الأعمال واستراتيجيات التكنولوجيا، رائد في الوسائط الرقمية، ومؤلف حائز على العديد من الجوائز، ومؤلف كتب متعددة، وهو رئيس سابق للإعلام الرقمي في شبكة أوبرا وينفري، ومؤلف حائز على العديد من الجوائز، وواحد من أبرز الواجهات العالمية في مجال البدائل غير المادية والاقتصاد الرقمي. تأتي مسيرته المهنية المشرقة كنموذج يلهم الجميع للتفاني والعمل الجاد، ونموذجا جادا في إدارة التغيير الرقمي والمؤسسي كذلك، وتحفز مسيرته على تحقيق الإنجازات المتميزة في جميع الميادين والقطاعات. بكل الود والتحية الخالصة نرحب جميعا بالمتحدث الرئيسي لمؤتمرنا هذا وضيفنا الدكتور روبرت تريسك ليلقي المحاضرة الرئيسية عنوان هذا المؤتمر، فليتفضل مشكورا.
Salam alaikum. Good morning. I want to thank the Ministry of Work for making it possible for me to visit here today, and to the group Media Thought for organizing this event. And I want to welcome everyone, all of our international guests, all the ministers that are here. I've prepared some special remarks for you this morning about the future of public finance, and a new kind of digital infrastructure. And this kind of digital infrastructure is ready to be built today, and I think it represents a future possibility for public finance. And the goal is ambitious. The goal is no less than to digitize the whole world. I know that may sound preposterous to some of the people here, but I know that this is inevitable, and today I'm going to explain to you why I believe that this is inevitable, why it's going to happen. And to begin, I want to invite you to consider a question. The question I have for you is this: what is the most complicated thing that humanity has ever built? As you think about that question, you might think perhaps something far-reaching, like space exploration, sending satellites into space. Or perhaps you'll think about something involving technology, like a microprocessor, the most energy-intensive device ever built, the microprocessor. But I have a different answer for you today for this question. I believe the most complicated thing that humanity has ever built is the global supply chain. The global supply chain. All those container ships. At any given moment, there are 5,000 ships on the oceans transporting 90% of manufactured goods around the world. You can think of the supply chain as a kind of a global network, a globe-spanning network that links cities around the world. This is an incredible achievement for humanity. More than 1 million companies in more than 200 countries. About 40% of the workers in the world are involved in jobs that are affected by the supply chain. And of course, everybody in the world is a consumer of the goods that are transported through the supply chain. And this incredible achievement of building this globe-spanning network, this achievement is the achievement of public finance. It's visionary public finance that has led to decades of investment in airports, container ports, roadways, transportation systems, multimodal transportation hubs, telecommunication systems, and everything else that links humanity together. This has increased prosperity around the world and has also preserved peace for many, many decades. Really, since the 1970s, we can trace the rise of nations like this one, Oman, and the growing prosperity to participation in this complex system, the global supply chain. Now, to build this kind of infrastructure at this scale requires a kind of balancing act, a fine balance, because most of the big public projects are partnerships, public-private partnerships. And when we do a public-private partnership, we have to balance the interests of private corporations that must make a profit in order to stay in business and continue to invest. But there are also the interests of the public. This is the public sector part. And there, the objectives are a bit more diffuse. The goals are broader and harder to define. The goals for public finance in a public-private partnership are to establish a prosperous economy, to create growth or drive further growth, and of course, to create jobs. But this is a balancing act because you have to balance between the narrow interests of private companies and the broad, diffuse interests of the public. That's not easy to do. And it's particularly difficult now because we live in a time of increasing risk. Risk is increasing around the world, and so when we enter a public-private partnership, the question we're trying to answer is, who will bear the risk? Will the public bear the risk, or will the private corporation bear the risk? And with the risks come the rewards. Increasingly, in public-private partnerships, we're relying more and more on private sector. Because of the increasing complexity, we need the expertise of the private sector, but that means that the private sector gains more of the benefit. And thereby we're less able to create the jobs and the prosperity that has succeeded for the last 50 years. You see the risks around you every single day. Where I come from in the United States, we're seeing fires now every year. I live in California. We now have a new season, fire season. Every year there's a fire. We just have our first big fire happening right now. In other parts of the world, this is occurring too. In the northern and southern hemispheres now, there's a fire season everywhere, from Canada down to Australia. It's not just fire. There's also the issue of heating up oceans, rising water levels. And this region recently experienced that just last month, when the airport in Dubai was flooded. So complexity is increasing because of climate change, but it's not just climate change. There's also geopolitical tension, geopolitical conflict between nations, and that too is starting to affect the supply chain. We just saw another tanker attacked by missiles in Yemen. And of course, in the Russian conflict in the Ukraine, some of the shipping was shut down, and that affected supplies of grain to many parts of the world, including Africa. And because of these conflicts, companies are reorganizing their supply chains. Sometimes the supply chain is getting even longer because they're routing things to different places. Or sometimes they're doing onshoring or nearshoring or friendshoring. So they're reorganizing the supply chain. And in the process also there are mergers and acquisitions, and this creates further complexity. So my point about these examples is simple. We live in a time of increasing complexity. The rising risks cause us to think very carefully about how to build infrastructure for the next century. Right? It demands a new approach to developing and building infrastructure because we're working in a very complex time. It's very difficult to forecast the future 50 years from now because of the complexity. So I want you to consider a new idea. Today I'm going to share an idea with you. A new approach to building infrastructure. An approach that will reduce cost, risk, and time, and increase the likelihood of a positive outcome, and it will create jobs. I know it sounds like a magic trick, but this is what I'm here to tell you about. We can build a new kind of infrastructure, smarter infrastructure. Today, there are technologies that are reaching maturity. These are technologies you're already familiar with. You've heard about them for many years. Artificial intelligence, real-time 3D visualization, the application of data analytics, the ability to gather rich data sets using Internet of Things and sensor networks. And together, these technologies allow us to build a picture, a visualization of the real world. We can digitize the real world. And that makes it possible for us not just to monitor and optimize current operations, but also to envision future scenarios and probabilities. You can ask a digital model questions about the future, and it will give you answers. It will show you what might occur in the future. This is smart infrastructure for the 21st century. It means that we will change every aspect of the way we develop infrastructure, from the very earliest stages where we envision, plan, design, and build. During the building process, we can see gains because we reduce the change orders. We reduce the need to revise the plan during construction. You build it digitally first, and then you build what the digital design tells you is optimal, and thereby you can reduce the errors and change orders that drive up construction costs. The same is true when you're operating. If you have digital monitoring, you can actually optimize the operations for maximum efficiency. You can A/B test, you can do multivariate testing that allows you to see different options that you could not see in the real world. And finally, a digital system like this will tell us when it's time to upgrade and how best to do that. I know this sounds maybe a little bit preposterous, and probably at this point you're wondering, who is this person who's talking to us? So, hello, my name is Rob Tersk, and what I want you to know about me is that for 30 years, I have been inventing the future. I've been invited by companies, corporations, and governments around the world to help them envision and design and plan new services that never existed before. I've never worked in a job that existed before I took it. In many cases, I took the first job in a new industry. And along the way, I've launched satellites in space. I've helped to build out new telecommunications networks, new ways to communicate, and new ways to connect. The services that I've designed are now used by hundreds of millions of people every single day. And I must tell you, at the beginning of each of these projects, there was some hesitation. There was doubt, uncertainty. But not for me, because I think very hard about the future. And when I start a project, I have certainty. I understand what's coming next, and I know how to build for it. And I'm going to tell you how to do that today. I'm going to share that with you. Over the course of the last 30 years, in every part of the world, whether it's in Asia or Latin America or North America or Europe or any place else where I've worked, I've been confronted by one big question. Every city, they've asked the same question. And I've actually found one good answer, an excellent answer for that question. And that answer is connected to three very large trends. These are what I'm going to tell you about today. I'm going to talk about the question, the answer, and the trends. Let's start with the question. So everywhere I've been, every city I've been to, whether it's in India or China or Asia, Southeast Asia or in South America or all over Europe, they always ask the same question. They say, how can we create a version of Silicon Valley right here? I mean, it's a really good question, right? Everybody wants to have a technological center that creates jobs and drives the economy and builds prosperity. But the sad answer, unfortunately, is that you can't do it. The unique circumstances in the 1940s that made it possible for Silicon Valley to emerge, that was a different time. That was many years ago. So if you wish to do that, if you wish to create a technology center that drives the economy and builds jobs, you have to find your own answer. You have to invent the future. Now we know that technology comes in waves. And so if you can understand what the next wave of technological change is, you can prepare society for that. And that is how you can take advantage of this change. The wave will drive your economy if you time it just right. If you're prepared for the technological change, you can ride that wave towards prosperity. We've seen this happen again and again and again around the world. Every 10 years, there's a major technological change, a new kind of technology or a new combination of technologies that makes new things possible that previously were impossible or very difficult to envision. Every 10 years, like clockwork, certain cities around the world have been prepared to take advantage of these new technologies, and those cities have emerged as world leaders. This time around, I think there is an opportunity here in Oman, in Muscat, and in the GCC region. This is your chance to win. Let me give you a couple of examples that you're all familiar with. In the late 1990s, the World Wide Web was already a growing phenomenon, but it was mostly academic. There was some government involved, but it wasn't really commercial. 1997 was the year when the web went commercial and became available generally to the public around the world. The web was a big shift because it changed computers from something that stood alone, separate, that ran code, to connected computers that could talk to each other. And you could see a page on another computer. You could recall a page or retrieve a page and see it on your computer. That simple idea is really at the heart of the World Wide Web, and that was transformative, particularly for the cities that were prepared for it. Of course, Silicon Valley, that region from San Jose to San Francisco in California, where I live. But also the cities of Boston and Seattle. They were prepared for this change. And it's interesting to consider that in 1997, Seattle was not considered a technology city. It was not a leader in technology. Yes, it was the headquarters of Microsoft, but even Microsoft was caught by surprise when the internet became a grand phenomenon. They had to shift the entire company or pivot. But they managed to do that. They managed to align business, private sector, public sector, and education and government policy. And these cities emerged as world leaders when the internet grew. Now, something we've all lived through more recently, just 10 years later, in around 2008, was the advent of the modern smartphone. And that is the shift from the desktop computer to the mobile web. And that shift, another big technological shift, created further possibilities. Of course, the companies in Silicon Valley benefited from this. They were prepared for it. But they're not the only ones who succeeded. You see that some new cities around the world began to emerge. Tokyo and Seoul. So in Japan and South Korea, they saw the future. They knew that the future was going to be small handheld devices, not desktop computers, but small devices that you carry in your pocket. And they aligned their business, their local industry and government policy so that they could be successful for this change. They knew how big the change was going to be. And so by 2008, they were ready for this. But the most interesting city here, in my opinion, is Helsinki. Helsinki was like Seattle. It was a lumber city. Nokia used to make rubber boots and lumber equipment, and then they became a mobile phone company. But again, the government in Finland was prepared for this change. They understood what was coming. They worked closely with local universities to prepare students, and they had a policy that fostered local innovation and technology. And as a result, Helsinki has emerged as a world-class leader in technology. And they managed to do that in a very short time, just a 20-year span. And it's worth thinking about it. The population of Oman is roughly the same as the population size in Finland. So a small country can emerge as a world leader. Once these cities achieve this status, they maintain it. It's easy to maintain it. Once you achieve the critical mass of technology, infrastructure, education, and startup businesses, it's easy to sustain that. It's hard to get this right the first time, but once you do, you can keep it. Now, we're seeing something similar happen right now around the world with artificial intelligence, and you're starting to see different cities around the world emerge as leaders in artificial intelligence. Not just Silicon Valley, of course, they're always there, but also cities like Beijing and Paris and Montreal. These cities are centers of excellence in artificial intelligence. So that's yet another wave of technological change. And even though artificial intelligence is still in its infancy, you can see that those cities have already begun to organize. They're organizing. And the way it looks is like this. You have to begin with enlightened government policy that supports innovation and change, an education system that trains and prepares workers for the future, and then a business environment that encourages novel technological solutions to arise, startup companies. These are the three key ingredients to creating a center of excellence. But then you need one more thing. You need industry. Local industry that serves as a champion. Local industry that will hire the technology companies to build solutions for them. Local industry that will hire the workers who are trained. If you can get these pieces right, then you have a virtuous cycle, and that will grow, and that's the beginning of building a center of excellence in a new technology. So you might be wondering, what's the next wave? How do we prepare for this? How can the city of Muscat and the nation of Oman and the other GCC states be prepared for the next wave? You have to know what's coming next, and that's what I'm going to tell you about right now. The next wave, in my opinion, is the shift from 2D to 3D. Today, if you look at your smartphone and go to Amazon or Google or even YouTube, they haven't changed much in 10 years. Those websites look very similar to the way they looked 10 years ago. They're still just a grid, a two-dimensional grid of images and text blocks. So it's a 2D web. That's what we're used to today. But 3D technology is rising quickly. And of course, 3D is how we see the world. That's how we're designed as biological creatures. We're designed to perceive the world in 3D. Why should we be restricted to a 2D web? Well, what's held us back in the past is processing power. It's been hard to render 3D, but now the technology has improved, and it's possible now to build in 3D. You can build 3D interfaces. The only question now is your nation or your city ready for this change? Are you prepared? Is government prepared to lead this change and to organize and orchestrate the whole economy? Now, some of you may be wondering, what is real-time 3D? What does that phrase mean? What does it mean to have real-time 3D? 3D software or 3D representation, this is not new. This has been around for 30 years. But we did not have fast processing power, and so it wasn't real-time. It took many weeks to render 3D. Very slow. So, for instance, if you think about movies, motion pictures, especially the superhero movies or the monster movies, the science fiction movies, those movies are filled with 3D graphics, computer graphics. But that's not real time. It takes months, sometimes years, to render frame by frame, to draw those pictures frame by frame. It takes a long time to do that. So that's the old 3D. That's not real-time 3D. But in the game industry, the requirement is that if I'm playing a video game and I take an action, I do something in that game, you have to see what I'm doing right away. That's real-time. It has to be instantaneous. And until fairly recently, real-time 3D, the graphic quality was not so good because it's hard to process all of that math. But now the processing power is improving, and as a result, we can do real-time 3D today with almost photorealistic quality, cinematic quality. It looks just like the real thing. It looks like a video. That's a gigantic shift. This is driven principally by entertainment, games, and more recently the metaverse or immersive worlds where you can participate and see in 360 degrees around you and interact with other people in those worlds. Now there's a new phrase they're using called spatial computing, and that's about mapping the real world with 3D overlays that align perfectly to the real world. They're registered to the real world, and you can see 3D data projected onto the world around you. And there's all sorts of other immersive entertainment coming. And the last thing I want to share with you is that 3D simulation is possible. We can actually build a replica or a digital representation of the real world. And then we can speed it up in time, or we can change some of the factors. For instance, we can model the effects of climate change on a city using 3D simulation. So as you can see, this technology began with entertainment, but it's moving into the real world. It's moving into industry. Now, you might wonder why I'm so certain about this. How do I know? It's because I follow the trends in the software, in the hardware, the computing power. Computing power has been improving steadily since the 1970s. You're familiar with Moore's Law. And for 50 years, Moore's Law governed the pace of progress with CPUs, the central processing unit. That's the brain of your computer. That's what's driving a machine like this. And the advances in CPU are what made possible the changes in the World Wide Web and the advances in computing and computer science. But recently, a new kind of chip has surpassed the CPU. It's taken the lead. This is the GPU, the graphical processing unit. As you can see from the name, graphical processing unit, this is optimized for rendering 3D. Now, if you follow Wall Street and technology stocks, you're familiar with NVIDIA. You know the company that makes the GPU is NVIDIA. And they're a very successful company. In some respects, they're the most important company right now because they're driving the pace of progress in the future. So if you want to understand what's coming in the next 10 years, all you have to do is look at what's happening with chips. And what's happening with chips is that the power of the GPU is increasing exponentially. Very important inflection point here in 2013. The rate of improvement for the CPU began to slow down. For 50 years, it had been governed by Moore's Law. And Moore's law is it's not a physical law, or it's not a law of nature. It's just a marketing observation about processing power in semiconductors. And what Moore's law tells us is that every 18 months, the processing power in a chip will double on average. What that means for the rest of us is that $1 or 1 real of computing power will double every 18 months. So you know from basic economics, when the cost of something goes down and the quality goes up, we're going to use more and more of it. And that is why we're seeing computing integrated into every aspect of society. But in 2013, the progress in CPU began to slow down. They had literally reached the physical limitations in silicon. You cannot add more transistors to a chip. And so the CPU progress has slowed. It hasn't stopped, but it's slowed. But if you notice something interesting on this chart, in the green line, you can see that GPU accelerated computing is expanding much faster. It's increasing at a rate that is much faster than Moore's law. It is increasing at an exponential rate, meaning that we are going to have processing power available to us that was unthinkable just 10 years ago. We can start to imagine things that were impossible just 10 years ago. And again, this means that the cost of compute will go down and the quality will go up. But GPUs are different from CPUs. The CPU in your computer is a multitasker. That's why it runs your computer and your phone. It can do multiple tasks at once. That's why you can run 10 different apps at once on your phone. A GPU is different. GPUs are for parallel processing. So it takes one complex task and breaks it into multiple functions that are computed simultaneously. So it's a different approach to computing. What types of problems can a GPU solve? Well, there are two very important categories: artificial intelligence and real-time 3D. This is why I can tell you with certainty that this is the future. Artificial intelligence plus real-time 3D. It's the power of increasing computing power in GPU that is going to make that possible for us. 2 years ago, I spoke to Jensen Huang, who is the CEO of NVIDIA, and we were talking about this trend. And I said, well, what does that mean for the regular person, for the average person? He said, Rob, it's very simple. Ask yourself this question: what will I do with a computer that is 1 million times more powerful than the computer I have today? That's the future. And that's what I'm going to tell you about. I'm going to tell you about what we're going to do with all that processing power. Earlier, I told you that there were three big trends that are shaping the world and changing the economy. The first one is dematerialization, taking physical things and replacing them with information. This is a trend that's much bigger than computing or telecommunications. This idea of dematerialization began in the 1970s. Ocean Tomo is a merchant bank in Chicago, and they published this chart a few years ago. And what this chart shows you is a shift in the factors that drive the value of companies on the S&P 500, the Standard & Poor's Index. And as you can see, in 1975, most of the value of a publicly traded company was in physical, tangible assets. But by 2015, most of the value was in intangible assets. What does that mean? What does that mean? Let me show you what I mean by that. The purple, the physical assets, the tangible assets, those are things like land, resources, capital, and labor that companies command. And that's how companies used to be valued. But today, as you can see, that chart has inverted completely. Today, more than 85% of the value of a publicly traded company is in intangible assets, intellectual property, patents, copyrights, trademarks, talent, the know-how in the minds of your employees, proprietary business processes that give an advantage, and most important of all, data assets have become incredibly important. These are the things that make companies valuable. This is the trend of dematerialization into software or into knowledge. Now, when I say that, you might think, well, that's a very strange phenomenon. We still live in a physical world. We still drive cars. We still eat food. What is he talking about? If you think about that smartphone that you carry with you every day, that you and 6 billion people on the planet carry every day, you notice that your smartphone keeps getting smarter Every year, it absorbs more feature functionality of physical devices. If you just go back, let's say 20 years, in 2014, if you were on an airplane, on a long flight, and you got up to walk down the aisle of that airplane, you would see people with a game machine, or with a DVD player, or with MP3 players. Today, nobody has those things. You can't even buy a DVD player. They're finished. Right? They become obsolete because all that feature functionality has been absorbed into one device, the smartphone. That's dematerialization into software. We're replacing physical products with software. And by the way, the companies that manufacture these, the consumer electronics companies, they have experienced double-digit decreases in sales over the past 10 years. They have been devastated by this shift to software. They were not prepared for it. So the term I use for this is vaporized. And in 2016, I published a book on the subject called Vaporized. I use that term because we're literally turning physical things into software that's available over the air, like vapor, like atmosphere. It's information on demand, like atmosphere. And it's truly transformative in the sense that you can do things under certain circumstances you could never do before. And no matter what you're doing, no matter where you are, if you find that you have a need for something new, you can simply download that to your phone. Now today we take that for granted, but man, 20 years ago, that was impossible. It was unthinkable. It's a major achievement. It's a major change. This economy, the growth in this economy has been phenomenal. In just a 10-year span, it increased fivefold. When I wrote my book, I interviewed W.I. Brian Arthur, an economist at the Santa Fe Institute. He focuses on complexity science. And he told me that the dematerialized economy is growing at twice the rate of the real economy. So if growth in the real world economy is 2.5%, the vaporized economy or the virtual economy is growing at 5 or 6% a year. And so at some point, he said, you can project it out into the future. Eventually, the dematerialized economy is going to overtake the real economy. It's growing at an extraordinary clip. And of course, that mobile phone has grown in importance as it's absorbed more and more functionality. It's become kind of a remote control for the whole world. You use your phone to control things, to call for a taxi, for instance, with O-Taxi, or to summon information or news when you need it, or to communicate when you're on the go. The other thing that happens when we connect everything together so that the smartphone can talk to it, we start to generate a lot of data. So let me show you what has happened in the last 20 years. First, we started with hundreds of millions of computers, and then we connected billions of smartphones. Today, there are about 6.5 billion smartphones in use around the planet. And of course, the Internet of Things, those smart devices, lights, other smart appliances in your home that your phone can talk to, there are tens of billions of those already today. And now increasingly, we're adding sensors in the roadway, in the environment, in our built infrastructure, inside of factories. And these sensor networks number in the trillions of sensors. This is an incredible scale of growth. And all of this has transpired in the past 10 years. And of course, when you have that many devices, trillions of devices connected, you're generating a lot of data. The economists called it the data deluge. And they said that 10 years ago. In 2010, we crossed an important threshold as a society. Humanity generated more than 1 zettabyte of data. What's a zettabyte? It's a funny word, zettabyte. You're familiar with gigabytes, right? That's how we measure data on our phones. A zettabyte is a million gigabytes of data. So if you think of a flash drive that holds maybe a gigabyte of data, now think of a stack of 1 million of those. Well, that would fill this room. And now think of 1 million stacks. Well, we would cover half of Muscat if we had 1 million stacks of flash drives, of 1 gigabyte flash drives. That's how much 1 zettabyte is. By 2014, we had increased that fourfold. By 2020, we had reached 44 zettabytes of data. And by 2025, we'll generate 175 zettabytes of data. This is the fastest growing thing on the planet right now, is data. And the companies that understand how to use data and apply it are the most powerful and important companies on the planet. Let's look at the big winners who started this change and now have benefited from it the most. Back in 2016, when I first published my book, Apple was the most valuable company in the world, valued at $570 billion. And what's interesting about that is just 10 years before, Apple was worth only $5 billion. They had a 100-fold increase, partly because of the iPod, where they digitized or vaporized music, and then the iPhone, of course, where they began to vaporize more and more things. But the other technology companies were also growing rapidly in value. That was in 2016. By 2018, Apple had added 50% to its market capitalization, and by the end of that year, by the end of 2018, they were the first company to reach $1 trillion in market value. And people thought this was crazy. How can a company be worth $1 trillion? But of course, they broke that threshold in 2020 during the pandemic, and by 2013, several of the tech companies were worth more than $1 trillion. And then people started to speculate what will come next. And some journalists said that these companies are on track to become worth $5 trillion. Folks, this is unthinkable. As recently as 2012, the most valuable companies in the world were valued in the 300 billion range. These are very large valuations. And of course, you know where I'm going with this. NVIDIA, the company that makes the GPU, is now the most valuable company in the world. They and Microsoft and Apple are all valued at over $3 trillion. Where will it stop? Or will it continue to grow? Will they reach $5 trillion in value? And if they do, how will they achieve that? How will they achieve that? I spoke to Kevin Kelly when I was writing my book. Kevin Kelly is the editor of Wired magazine, and he's been writing about technology for many years, someone I respect tremendously. And this is how he described it in writing. He said, we're at the dawn of the third platform. The first platform was the web. The second platform was the mobile web. And the third platform, we will digitize the whole world. We're going to digitize the real world. Whoever dominates this process, whoever dominates this third grand platform, will emerge among the wealthiest and most powerful companies in the history of the planet. Think about that for a second. That is what these companies are aiming for. They are driving towards the digitization of the planet so that they can become more powerful and more valuable. And along the way, they're going to make use of your data assets. And when I say your, I mean the people of Oman. The data that is sovereign to this nation is going to be something that they take and use and build their value with. Can public sector finance address this? Is there an opportunity for public finance to do something about this so that you can capture some of that value and return it to the people of Oman? That is what I'm here to talk to you about today, and I believe it's possible. So just to recap, the first trend was dematerialization, where we began to replace physical things with software, and that was made possible by the increasing power, the computing power. Then hyperconnectivity, where we began to connect devices around the world to our smartphones. And that process is now very mature, and it's well underway. And in the process of hyperconnectivity, we began to generate gigantic data assets. And those data assets are now being used to train artificial intelligence systems for the big tech companies. The next phase is that we will use both of these to begin to digitize the real world. Now, you probably wonder what this looks like. I'm going to show you what I mean. I'm going to start with a very simple example, maybe a silly example. If you think about a sneaker, a high-end trainer or a fitness shoe like this one, it's probably designed by a sportswear company, maybe in California, where I'm from. But it's probably manufactured by a factory in Southeast Asia. So the shoe is designed in one place and built in another place. And when we buy the shoe, what we think we're buying is the physical product. But what you're paying for is the invisible data around that product. I know that seems strange, but for every shoe on the planet, there's a cloud half. There's a data half. It turns out there's a ton of data. There's a lot of data inside of a simple product like a shoe. First, there's all the design data that was used to design that shoe, and sometimes that's quite sophisticated. You know, they're using computer models to design athletics, and they're using that information to optimize the shoe. But there's also all the marketing, all the media that's associated with that brand and with that shoe. That's what makes you aware of it, and that's what makes you want to buy it. And so there's huge value in that marketing. And then for some products, there's also other types of data associated, things like warranties and guarantees and manuals on how to use them, sometimes upgrades, software upgrades to products and so forth. So for every product in the world, there's a cloud half. Certainly the shoe has a cloud half, a data half of the product. We don't see it, we can't touch it, we can't measure it, we don't understand it. The technology companies do. But every product has a cloud half, not just a shoe. Every product that is made, half the value or more is in the data around that product. That's true for every machine. That's true for every building, every warehouse, every transportation center, every seaport, every airport. Entire cities have a cloud half. Today, that data is dissipated. It's not captured by anyone. And if you don't do anything about that, the big technology companies will figure out how to capture that data, and they'll collect it and use it for themselves. And that is why I'm here to tell you about digitizing the world yourselves. This is the future of public finance, digital twins, large-scale 3D digital representations of real-world places and infrastructure. For every seaport and roadway and train that is being built in this region, you must consider how to build a 3D representation for it, how to capture the data that flows from that product, and how to apply that data to running it, optimizing the operations of it, and planning for the future, and planning for the increasing risks in this complex future. Today, most manufacturers of automobiles are very focused on this. If you buy a Porsche or a Tesla car, those manufacturers have a digital twin of that car because each car is going to have different wear and tear and different experience as it's driven around. And the manufacturers track that. Those cars are connected to the internet, and so the manufacturers gather that. That's also true for jet engines. If you buy a jet engine for an airline today from Boeing or Rolls-Royce or any other manufacturer, that jet engine comes loaded with sensors, and that sensor data is collected by the manufacturer so that they can measure the wear on that particular part, because every jet engine wears slightly differently based on atmosphere and other conditions of use. So manufacturers already understand this. They're already building digital twins of their products, and they're also building digital twins of their factories. Today, for most big-scale energy production, there will be a digital twin associated with that to monitor and manage the operations. That's also true for automobile manufacturing. Today, every auto factory's body shop has a digital twin. That is to say, a digital representation or representation in data of that factory. They must do this because most of those factories, the body factories for automobiles, most of those factories are robotic. There are no humans inside of those factories. You can think of an auto body plant as a big machine. You put parts in one end and finished auto bodies come out the other side. And inside, it's all built by robotics. So for the managers of those plants to understand what is happening inside the factory, they must have a digital twin. That's how they see what is happening on the floor. It's not just a visual representation. It tells them data about what's working, what isn't working, what's optimal, what's suboptimal, what they need to fix, and what they need to attend to. Now, 3D digital twins are leaving the factory and they're starting to enter the supply chain. And so we're starting to see companies around the world focus on building robotic shipping, container ships, robotic ships, and also airplanes in the sky. And these are very sensitive pieces of equipment, so they need to be monitored for possible problems, fatigue, parts that need to be replaced. So it makes good sense to invest in this. But gradually, we're starting to see things like oil rigs as well, and other energy infrastructure will have a 3D digital twin. This is an example of a port in Finland. Cytowise is a port in Finland. And the company Unity built this real-time 3D digital twin that shows you conditions of the shipping. And so you can track every container ship. Every time there's a delay on a container ship, the economic costs are tremendous. You know this. We lived through this during the pandemic when shipping was delayed all over the world. But also, water level matters. If a container ship can go 1 foot deeper in a harbor, they can add 50,000 more shoes, and they can actually sell millions of dollars more shoes. That's actually great for local prosperity and local economy. And so it's very useful to start to build a digital twin of your seaport so that you can monitor conditions in that seaport as ships are coming and going and optimize that part of transportation. The same is true with airports. Around the world now, we're starting to see 3D digital twins built of airports. An airport is a very complex space. You can think of it as a small city. And it's a three-dimensional space because you have aircraft in the sky and vehicles on the ground and pedestrians inside and so forth. So what we do with an airport digital twin is we model the inside and the outside in real-time 3D, and that allows workers at the airport to see every aspect of the airport. Now, there's no place in an airport where you can see everything just with your eyes. So this is necessary. This is a way to empower workers and make them able to make better decisions about what to do. So what we're building then, if you think of this, is a series of digital twins that could be connected together into an automated machine-readable network. Machine-readable is important. That means that we can have robots managing these things. So if you've heard the phrase, software is eating the world, or software is devouring the world, and I believe game engines are going to make it possible for us to program the world. A game engine is a simulation tool. It's a library of physics and other mathematical equations that allow us to build 3D worlds. And of course, these were developed for games. So as you can see on this chart, when we build something for a multiplayer game, in the digital twin for industry, that means multiple users can cooperate. When we build something that spans mobile or maybe virtual reality, that means that workers can now experience 3D on any device that they have. It's cross-platform, runs on any device, any cloud. If we build a game simulation, all games at some level are a simulation of a virtual world. That means we can apply that to simulate the real world. And of course, a game requires us to have the ability to know what other players are doing in real time. And that's an incredible benefit for digital twins for industry, because it gives us the ability to understand what's happening in the real world live. You don't have to wait overnight for that data to come in. Real-time insights. The company that is a leader in digital twins in the world is Unity. They provide the world's most popular game engine. It's used by about 75% of game developers and virtual reality developers around the world. And today, that game engine is being used to build 3D digital twins for industries in many different fields. Of course, entertainment, games, film production, the metaverse, and so forth, but also for education and training. Immersive training with 3D is incredibly powerful. It's very persuasive. It's a very good way to train people. You can train people on systems that haven't even been built yet. We also use this for urban planning, land use planning, transportation planning, city services, the provision of city services, and the optimization of those services. It's used in aerospace, transportation, architecture, engineering, construction, and also for energy, mining, agriculture, and for managing the environment. So there are many ways to use real-time 3D twins. And they're transforming the way companies work. Because now companies can see the future. They can envision what's being built. They can start working with it before it even exists. We use them in the design phase. So in this example, you can see that the old way of designing a car was to carve it out of clay. The new way to design a car is to build it virtually. And that means you can make changes on the fly. The whole design team can work with a virtual model of the car, and you can literally change parts. You can replace them, you can make new designs, and so forth. It reduces cost and time in design. The same thing is true for large-scale infrastructure. In the old days, we built small models, usually on a cardboard, on a tabletop, of a new bridge or a new roadway. But today, we can design in real-time 3D. And because of the game engine has physics and weather, you can see what happens to that bridge or that other infrastructure when there are extreme weather conditions, when it's populated with vehicles. These are things you cannot do with CAD or other 3D tools. This requires a game. In construction, we're seeing tremendous cost savings. In the past, construction planning was done with blueprints. Not everybody can read a blueprint. That's why you often have cost overruns, because there are change orders when construction happens. With 3D digital twins, we can ensure that what's being built is exactly what was planned. This reduces cost overruns. We are saving hundreds of millions of dollars in construction costs and delivering projects on time with zero defects using digital twins. The same is true for marketing. Now customers can envision the product in their situation, on site. They can envision the use of that product. They can begin training workers on that product before they make a purchase. And once the product is installed, or once the tool or system is installed, you don't have to refer to a manual, a paper manual. The workers can use a heads-up display, virtual reality glasses, and they can see exactly where to make a change or exactly how to manage or maintain a part. The same is true for mineral resources and geography. In the past, the way we measured data here with these numbers, charts, you can't even read it. Humans can't understand that. But now we can visualize it. And what's important is it's multi-user so that everyone can see the same thing. We all have the same understanding of what's happening. This is incredibly important for mining, energy production, and land use planning. All of these systems are machine readable. That means artificial intelligence can be trained on these models and applied to them. In other words, this is a way for humans to understand what the machines see. When we see a 3D model, we're seeing exactly what the machine sees. And so when we train a robot vehicle to drive on the streets, it's looking at a digital twin of that city. That's how the robot vehicle is trained. And the same is true with the planning and use in retail environments, like the bottom picture shows. What I'm proposing to you today is a city-scale digital twin, and I think Muscat might be the right place to start. This is a place in the world that has benefited tremendously from enlightened public investment in infrastructure. Now I want you to consider digital infrastructure, building a large-scale digital twin to optimize current operations and plan for the future, to plan for an increasingly risky future. What we're proposing is nothing short of a smarter city. You've been hearing about smart cities for years, but we haven't been able to envision them in 3D. Now we can. Now, because of the advances in GPUs, we can start to see the smart city. We can see the city systems at work. We can see the parts that need to replace, and we can see them at any resolution, any scale, including all the way to a close-up. We have built city-scale twins in Singapore, Orlando, Paris, and Vancouver. Your city could be next, and there are tremendous benefits to the local economy when that occurs. What I want to propose to you today is something radical that hasn't been done yet. You could be the first. I'm proposing to build a city as an open model that other companies can innovate on. This might be something that's built and managed by the city, but it's open to small companies, big companies. Everyone can build on top of this. This would turn the city into a software platform for innovation. And that would be a data asset that is owned by the city, owned by the government, owned by the people, not by a company in California. So again, it begins with my simple model from before. Enlightened government policy that sets forth a vision of a 3D digital twin for the entire city. Then you'll need to start to train workers. But there are many good universities here. You have the right thing. You're starting with the right education infrastructure. We just have to create a program for a center of excellence in 3D, spatial computing. That creates the talent that can then go work at technology companies that are experts in developing 3D models. And of course, that's virtuous because those companies will begin to hire those graduates. That creates more jobs. So thanks to the Ministry of Work for making this talk possible, you can see that this can actually start to drive good jobs for the people of Muscat and Oman. That's a good self-sustaining model. But then when we add in industry, this is where it really gets big. Now, if the government doesn't step in, if the government allows this to happen in a free market way, well, then what you'll see is that small companies will start to build software, custom software for every one of the industries. But these models will be separate and wholly owned, and they won't interact, and they won't be consistent, they won't be standardized. They'll be separate, discrete models that do not interact. You'll have no network effect. However, if the city decides to build a city-scale twin, a common architecture, a common infrastructure, then you can align platform, this turns the city into a platform, and you can align the solutions so that they all operate and they all feed data into the same system. That will actually give the city an advantage in terms of managing resources and understanding the different demands. Say, for instance, weather conditions and the ability to simulate future weather, or energy demands. You'll be able to model energy demands. I'm working with a city that wants to understand their water supplies 100 years in the future. That's their challenge. And we're helping them design that so that they can understand how there'll be enough water for all of industry and all of the people in the city. So if you build a city-scale twin, that can help you achieve what the founder of Amazon calls the flywheel effect, where there's enough momentum that it continues to sustain it. And this is how you build your version of Silicon Valley. This is how you build a technological center of excellence. Because if you have the education, the software solutions, and industry working together on a common platform, it's going to create good jobs, it'll grow the tax base, you'll have prosperity in the community, but also you'll be able to attract more companies to this region because you have the expertise, you have the technologies that they're looking for, and eventually you'll be able to export those technologies to other places. And the supply chain is the perfect place to begin doing this because the supply chain is already interconnected. You get a network effect. Now, you might wonder how. So in the remaining just couple of minutes here, I'm going to show you an example. Because sometimes when I talk about this, people think, wait, what is it you're talking about? How will we do this? We don't have any of those things here today. I want to show you how easy this can be to do right here in Muscat. The concept I've developed with a collection of partners is called Media Cube. And Media Cube is designed to be a center of excellence for real-time 3D and the home of a city-scale digital twin. The Media Cube is about applying 3D to the real world. First, for entertainment, live performances, so that's how you get people excited about this new technology. And then an academy to train people in these skills and to professionalize the workforce. And third, exhibition space to show people what is possible. And fourth, a place to design solutions for industry. So that is all contained in a single building. And as I spoke about this, I encountered an architect who said, this is amazing, we need to build it. The architect is named James Law, and he's built a number of buildings in the Gulf region, including in Abu Dhabi and in Dubai. He's built these futuristic buildings. He immediately took one look at this and said, I can design it. And he started doing a design for it. Here you can see a cross-section. And so in the top part of the Media Cube, there's a large entertainment and exhibition space, and then underneath that, there are spaces for the academy, for exhibitions, and for business, for the design agency to be housed. This is something that's open to the public, so that the public can become aware of this and get excited about it. It's also there to serve local industry. And that's his rendition. That's how it will look. This giant gleaming cube covered with LED lights. You'll be able to see it when you're flying into the city. Inside the dome, there'll be live performances, giant avatars, immersive media performances, something like the MSG Sphere in Las Vegas. You can have that here. And of course, the students will be learning how to build those, how to design those services. But the building will also be a demonstration center to educate the public on the possibilities of these new technologies. And it'll be an exhibition center so that you can showcase the best of what is coming. Education is an important part of the Media Cube. It's the heart of the Media Cube. It'll be education in 3D technology and digital media and computer science. So we'll start with computer science, robotics, artificial intelligence, teaching students how to do spatial computing and use 3D to build models of the real world. We'll teach students game design because that's a core skill. If you're going to do this, you need to understand how game engines work and how to author interactive media experiences. So this is designed to increase the skills in the workforce so that these people are prepared for the 21st century and able to build the kinds of solutions that industry needs. But ultimately, this is here to serve industry. And we will build a full-scale digital twin of the city that will be used for planning and simulation for future scenarios. It'll be there to support the industrial metaverse, to build digital simulations for the logistics and supply chain centers, and also a way to develop 3D models for precision manufacturing, and a way to visualize remote facilities, such as energy production facilities. All of that can be done with this digital twin. So that's it. That's the vision for the future I want to share with you today. I've enjoyed speaking to you tremendously. I appreciate your attention. Thank you very kindly for bringing me to Muscat, Oman, to share this vision with you. I'm Robert Tersk, the author of Vaporized. Thank you.